Hello and welcome back to Serpent Sunday. As always, I'm your host, Morgan. Now, I'm sure you've noticed that Serpent Sunday has kind of been gone for a while, and that just has to do with my own personal scheduling. I am in my last year of college. I will be getting my biology degree in June, and sometimes the videos that I have planned for Serpent Sunday, I just don't have the time to do the research for them. So Serpent Sunday will continue, just not every single Sunday, but there will be videos out on Sundays. This week, we're going to be looking at a Science Daily article that is kind of summarizing some research that has been done in Guam, where we have learned about a brand new form of serpent locomotion. And this is very exciting because up until then, there have been 4 documented modes of locomotion that snakes use. And so we're going to talk about this new mode of locomotion and a little bit about why it's troubling on an ecological level. So without further ado, let's get into this. All right, so this article is linked down below, but let's just read a little bit of it together. It is not too terribly long, but I would like to read through it with you. And just because I think it's very interesting. So, the article itself is titled, "This Tree Snake Climbs with a Lasso-like Motion." Researchers reporting in Current Biology on January 11th have discovered that invasive brown tree snakes living on Guam can get around in a way that had never been seen before. The discovery of the snake's lasso-like locomotion for climbing their way up smooth vertical cylinders has important implications, both for understanding the snakes and for conservation practices aimed at protecting birds from them. So, with the snake's general climbing motions, if you have a wide enough, smooth enough surface, in general, they're not going to be able to get up it, so you could potentially protect birds from them. That's why this is a bit alarming, and that's why they're mentioning that they're climbing up these smooth vertical cylinders, because in the past, this was an easy way to protect these arboreal animals, specifically these birds, from these invasive tree snakes. Our most important finding is a new mode of snake locomotion, says co-senior author Julie Savage of Colorado State University. Only 4 major types have been recognized for nearly 100 years, and we have discovered a 5th mode. The discovery of a 5th mode of locomotion, in additional to the known reticlinear, lateral undulation, sidewinding, and concertina modes, was a matter of serendipity. Savage was working on a project aimed at protecting the nests of Micronesia starlings, one of only 2 native forest species still remaining on Guam. Okay. So that paragraph has a lot of big words, but the important thing is they weren't necessarily looking for the new mode of locomotion in snakes. Discovering it was kind of an accident because, as it mentioned, there are only 2 native forest species of birds left on Guam. So a big thing has been trying to protect these birds from these tree snakes. And up until recently, these large vertical smooth cylinders around nest sites and things have been the way to do it, because based on the 4 known modes of snake locomotion prior to this discovery, a big smooth cylinder means the snake can't climb up it. So I know we've probably all seen videos of the boas climbing up the palm trees and things in this very cool motion. Well, they can do that because palm trees aren't smooth. There's places for them to easily grip. So a big smooth cylinder would give them problems. And in general, even if you put a snake on a very smooth, flat surface, they're not really going to move forward. I've noticed this with my own snakes at home. If I put them on something that's too smooth, they just kind of stay in place even though they're clearly trying to move. And it's kind of an interesting thing to look at, and you can see videos of it coming out of research labs and things like that, the different modes of locomotion, and it is very interesting to see. But so moving on with the article, people accidentally introduced the nocturnal snakes to Guam in the late 1940s or early 1950s. Shortly thereafter, bird populations started to decline. It is now recognized that the invasive snakes have decimated forest bird populations on the island. They are also responsible for extensive damage and many power outages across the island each year. Most of the native forest birds are gone in Guam, says Savage. There's a relatively small population of Micronesian starlings and another cave nesting bird that have survived in small numbers. Understanding that brown tree snakes understanding what brown tree snakes can and cannot climb has direct implications for designing barriers to reduce the dispersal and some of the deleterious effects of this highly invasive species, says co-senior author Bruce Jane of University of Cincinnati. So up until now, these snakes haven't been able to climb these smooth vertical cylinders, or at least we don't think they could. So now that there is evidence that they can, and there's this fifth recognized snake locomotion, it makes this whole conservation of the birds on Guam and the ecosystems there that are being disrupted by these invasive species very problematic. While it is super neat and I love snakes, snake locomotion is very interesting. It's super cool that we found this fifth mode of locomotion. It's also concerning at the same time because it's going to make protecting these birds a very new and more difficult thing to do when it's already difficult because, again, these snakes are invasive and this is not necessarily... It's an exciting discovery, but at the same time, it's a concerning discovery. A lot of times when we have discoveries in science, they're not always exciting, but there can be this kind of flip side negative implications of a discovery. So moving down a little bit in the article, we didn't expect that the brown tree snakes would be able to find a way around the baffle, Siebert says. Initially, the baffle did work for the most part. So the baffle they're referring to is explained in the paragraph above, where they were keeping these snakes from being able to climb up to nesting boxes provided to help promote the population growth of these birds. And again, the baffle is just this big vertical smooth cylinder. Initially, the baffle did work for the most part. Martin Kastner, a CSU biologist, and I had watched about 4 hours of video, and then all of a sudden, we saw this snake form what looked like a lasso around the cylinder and wiggle its body up. We watched that part of the video about 15 times. It was a shocker. Nothing I'd ever seen compares to it. Jane explains that snakes typically climb steep, smooth branches or pipes using a concertina locomotion, bending sideways to grip at least 2 places, but lasso locomotion is different. Using the loop of the lasso, the snakes form a single gripping region. So, yeah, it's interesting, but this is going to make the conservation of the birds much more difficult. And as of right now, I don't know if this is the only population of snakes that use this form of locomotion or if they're going to discover other populations using it as well. And this is just one that's never been observed before. That's the big update kind of in the snake world right now. So while it's exciting for snake locomotion researchers to have this fifth mode of locomotion to now start studying and trying to figure out, is this the only population of snakes that uses it, or is it elsewhere? Did it evolve just in the population of these tree snakes on Guam in the recent years to get around these conservation efforts? Does this happen in other arboreal species? It's also a big thing that's going to have these negative implications for the conservation of the bird species that are struggling to survive this invasive threat on Guam. That's all I really have for you this week. I know this has kind of been a short and simple one. The article itself is linked down below, and they do have the research article linked as well in their resources. I don't know for sure if it's available to the public or if you can only access the abstract for free, but it might be worth checking out as well. I do hope that you have a wonderful rest of your day, and I will see you all in the next one.
Thank you again for watching this video. Don't forget to like, comment, subscribe, and ring that bell if you would like to see more. And if you'd like to follow me on any of my other social medias, the links are down in the description below. Don't forget to check out thereptilegoth.com for all of my articles and blog posts. If you found any value in this video and you would like to help support the channel, please check out my Patreon page. That link is also in the description down below. And a special thanks goes out to my Diamond Dragon patron, Diane V. What you're doing is really helping me fund a dream here. I will see you guys all in the next one.